Okay, today we want to look at ray optics. And when we look at ray optics, what I want you guys to realize is that we're now going to treat light as if it travels in perfectly straight lines, which we call rays. This is kind of like the way you would have drawn things back in kindergarten with light coming off the sun in beams of light. So forget about the wave nature of light, forget about interference, forget about polarization and all that other stuff, and treat the light as if it travels in a perfectly straight line. Okay, the first example we're going to do is basic reflection off of a flat surface. So the first thing you realize is this is a mirror down here. This is a beam of light coming in and striking the mirror. And what you want to do is you always want to draw a normal line, which will be an imaginary dotted line that is perpendicular to your mirror surface. So it makes a right angle with the mirror, and realize that we draw that normal line so that we can measure the angle of the light from that normal line. So this angle is called your angle of incident. It is the angle with which the light comes in and strikes the mirror. And for reflection, the angle of incidence will always be equal to the angle of reflection. So this angle that the light bounces off the mirror will be the same as the angle that the light came in. We're going to call this the angle of reflection. And although it may not be perfectly drawn here, realize that this angle of reflection will be equal to the angle of incidence. Okay, we have two types of reflection. Reflection off of a flat, smooth surface. That's going to be called specular reflection. And these parallel rays of light, according to the law of reflection, will all bounce at the same angle, so they will remain parallel. This is the type of reflection we would get off of a smooth surface, like a mirror, a piece of glass, or a calm lake. The other type of reflection is called specular, and this is off of a rough surface. And each of these beams, when they hit, is going to travel in some different direction. So some may travel in the backwards direction, some may travel in this direction, and some may travel straight up. In general, they'll be going every which way. This type of reflection is what we get off a rough surface. We are not going to be able to produce images with diffuse reflection. So we have diffuse reflection and we have specular reflection. Okay, specular is the one off of the smooth surface, diffuse is the one off the rough surface. Okay, when we have specular reflection, that would be the type of reflection we get in a mirror. Realize that when you see this image, it's not actually on the surface of the mirror. The surface of the mirror may be creating it, but our mind doesn't actually focus on the surface, but we actually focus in some area behind the surface. And that area will be equal to the distance the object is in front. So you can see where his fingers are. They're both just about on the surface of the mirror, but where his face is, there is some distance between the surface and where his facial features are showing up. We can see this really well in this video where it looks like I have two candles on the table, but only one of the candles is real. So when I put a wine glass at the spot where it looks like the image is, you can see that that image can burn underneath the wine glass because it's not a real candle. It's just a reflection of the candle that's in front. So when I pour water over the second candle, it does not go out because it is not really there. Why is it that it looks like it's there? Well, you want to look at this thing and realize that we are seeing a candle, a mirror, and a person's eyeball. And what's going to happen is light from the candle travels in all directions, but one of those directions will hit the mirror and bounce into our eye. Our eye and our brain process this information, and we believe that the light originated in a straight line, and that straight line would trace backwards behind the mirror. When we look at the bottom of the candle, that too will trace back to a spot behind the mirror, and our brain puts this all together and thinks that it sees a candle behind the mirror. The distance the candle is in front of the mirror, DO, which stands for distance to the object, will be the same as the image is behind the mirror. That's called DI for distance to the image. Okay, the next type of mirror that we'd like to look at is a two-way mirror. This is the kind of mirror that they might have in a police interrogation room, where from one direction it looks like a mirror, and from the other direction it looks like a piece of glass. To see how this works, let's imagine that we are the bad guy who happens to be in this room here. Okay, you'll notice that this room is really bright, 500 lux. Okay, so when that light is coming off of this guy and striking this piece of glass, it's important to realize that this glass is half silvered, so half of that light will bounce right back to the person in this room. And assuming the brightness of the original line was 500, the brightness of this reflected line will be 250. There will also be half of the light traveling through that half silvered mirror, reaching the person in the dark room. That will also have an intensity of 250. Okay, then when we look at the situation from the person in the other room, we realize that they have a much weaker beam of light bouncing off of them, and if 50% of that bounces back, it may have a strength of only 2.5. That is so weak that it will be totally dominated by the 250 that came through the glass. So this person in this room is going to see the bad guy, and they're going to assume that this separator is a piece of glass. This green line represents again the light coming off of the person in the dark room. Half of it bounced back, half of it travels through, so only 2.5 actually makes it into the other room. That is so small compared to this reflected beam that the person in the light room is going to see the reflection. That means that they are seeing the separator as a mirror.